Hey guys, this is Mr. Riz. So we're going to start 1-3 here, which is piecewise functions. So these notes are going to be a little bit longer than normal, or it's going to be kind of different from what you guys will do on your CYU. With everything going on, we're just going to make sure you guys can evaluate the CYUs and not so much be able to graph a piecewise function. But we'll go over them in our notes. It's good. If we can graph them, you should have no problem evaluating them. So our goal here is to make sure we can graph and determine piecewise functions. So we got a good example problem here just to help us warm up and explain what a piecewise function is. So let me go ahead and start to annotate on here and we'll get this going. So we got Elena. She has a summer job as a lifeguard. She makes $8 an hour for up to 40 hours each week. If she works more than 40 hours, she makes 1.5 times her hourly rate, or $12 an hour, for each of her over 40 hours. How could we make a graph and write a function that shows Elena's weekly earnings based on the number of hours she worked? Okay, so if we look here, she has like two different scenarios. So if she works less than 40 hours a week, she makes $8 an hour. So the way we could write that here is like we could have a function f of x, and we could say like, okay, she makes $8 an hour, so 8 times x. But that only is when she's working less than 40 hours. If she's working more than 40 hours, she makes $12 an hour. Right? Well, kind of. For each hour over. Okay, so actually we do have to change that a little bit. So let me see how we want to do that. Let's think, because it's not just like 12, because if she works 41, she doesn't get paid. She gets paid, yeah, a different amount. So it's not that, it's going to be, let's see, how could we write that? Let's clear it off. Well, let's see, let's clean this first part up. Think about what we're doing here. We're only working $8 an hour for every 40 hours she's working, right? So that would be whenever her hours are less than 40. We'll put this little key thing here. But when she's working something else, it's going to be different. She's going to make $12 an hour for everything over 40. So that I think I just said it the way right there. She's going to make $12 an hour for everything over 40. So if we take x minus 40, so if she works $41, she gets 41 hours, she gets one extra 41 for x, so one extra $12. All right, then plus 8 times x for when x is greater than, or yeah, greater than 40. We'll actually put it less than or equal to. Now, if we think about like on a graph, what would this look like? And we'll go like 10, 20, 30, 40, 50. Oh, this should be 30, 20, 10. Okay. So you think about it. If she works 0 hours, she starts making 0. And then she's making $8 an hour after that. So we're going to have a graph. So after 10 hours, okay, she'd be up at 80. 20 hours, 160. 30 hours, okay, at 80 more, 240. 40 hours, okay, 320. But after 40 hours, there's going to be a change, right? The graph isn't going to be a straight line like that. After 40, she's making overtime, so it's going to start going up higher, which makes sense. So what we had to do was kind of split the graph into two different functions. Now, the other function was kind of a little bit difficult to think of, okay, because we didn't want to pay her too much. We couldn't just do 12 times x, because that means like if you work 41 hours, your boss is going to pay you $12 for the whole 41 hours instead of just $8 for the first 40 and then one extra. So we had to make this extra little piece here. But this works for here. So what we have here in a piecewise function, we have these ranges that determine what function we're going to follow. So if I wanted to say she's going to work 32 hours a week, I'd plug 32 into this equation. I can figure out her total. But then I say if she's got a busy week and she's going to work 54 hours, well, 54 is more than 40. I'd plug 54 into this equation, into both of those there. To the bottom equation, I'd get the answer. Okay, so hopefully that kind of helps you guys out with what a piecewise function is. A piecewise function is really two functions or more that gets broken up, and depending on what our x value is, determines which one we're going to plug it into. And that's going to be a big thing for the CYUs. So if we have to graph a piecewise function, what you might want to do is to plot some points. So if you notice here, we have this piecewise function that's actually broken down into 3 points. We have from -10 to -2, we're going to follow this first equation here. And so what the person did here is they plotted those points. This one's actually kind of nice and neat because we do have a slope and a y-intercept. But we can just find one of the points here on a graph. So if I pick like -8 and I plug -8 into here, see -8 times 4 is -32 plus 11 would be -23. So we have a point here. Did I do that right? Yeah, -23 should be right here. Oh yeah, these aren't spaced out nice. And then going up 4 by 1. So it follows this. Now this next problem here would be for the points between -2 to +2. So we're going to plug those points in here. It makes it nice. We plot those points, our middle point graph here. We plot it here and we get a nice curved shape. Just plugging in, okay, plug in -2, or plug into that, okay, that'd be 3. Plug in -1, that'd be 0. Plug in 0, that'd be -1. Plug in 1, that would be 0. And plug in 2, that would be at 3. And just plotting those dots here. And then lastly, we got another equation. So I'm just going to plug in numbers like 2. If I plug in 2, I get 3. Plug in 3, I get 4. Plug in 4, I get 5. Just keep plugging those numbers in and plot that third line. So what might be better to do is just to make a big table of everything. Now, it's not the quickest method, but it is a really reliable method. So piecewise function, if you look at, if we have 3 different functions here, we're going to have 3 different ranges that changes. But on a graph, we're just going to have 3 little short segments that we hopefully connect together. They don't always have to connect together, but they might. So let me move my noggin here. All right, let's go ahead and start figuring this out. What you might want to do is to make a table. So let's go ahead. Let me get my annotations here and let's start with the first part. All right, I'm going to start here. So we're going to make a table for the first part, X and Y. And we're going to use all the values from -4 to 0. -4, -3, -2, -1, and 0. This is not the quickest way, but it's a very efficient way. So I'm going to plug these numbers into the top equation. I'm only plugging them into the top equation. So I'm going to plug in, well, -4. If I plug it into this is a constant. There's no x, so it's just going to be 3. And plug this one in. It's still going to be 3. Plug 2 in. Since there's no x here, it's still going to be 3. Plug in 1, 3. Okay, so if we were to plot these points here, we're going to do it. Now, I'm going to work backwards here for a reason. All right, 0 would be at 3. All right, -1 would be at 3. -2 would be at 3. -3 would be at 3. Now, -4, we have to be careful of because -4 is at an end range. If we look here, this is just a less than symbol, not a less than or equal to. So I need to make that an open dot. 0 was a greater than or equal to, so that needed to be a solid dot. If we look here, connecting the points in between would make a nice solid line. So there's the first part of our graph. Next part would be, okay, let's get a different color here just to switch things up. All right, we're going to make another table here. And we're going to pick every number between 0 and 2. So 0, 1, and 2. All right, we're going to plug them in. If I plug 0 into -x, it would still be 0. If I plug 1 into -x, it would be -1. And if I plug 2 in, it would be -2. So we'll plot those points. 0 at 0, and we're going to make a solid dot because that is less than or equal to. 1 is in the middle, goes to -1. And then 2 would be a solid dot because we do have a greater than symbol here at -2. So we'll connect those. And then we got a third equation here. So we'll make another third table. X's and Y's, and we're going to pick every number in between. So starting between 2 to 4. So 2, 3, and 4. So let's plug 2 into here. 2, 3 minus 2 is 1. Plug in 3, 3 minus 3 is 0. Plug in 4, 3 minus 4 is -1. Just got to be careful here because 2 is a less than symbol, not a less than or equal to, just a less than. We're going to start with an open dot. And so at 2, 1, we'll start with an open dot. And then 3 goes to 0. And 4, that's our ending point, which is going to be open because it's a less than. connect. Now, if you're confused on whether, okay, do I start with an open or close, just look at our ranges here. This starts with an open, ends with our close. So our graph starts with an open, ends with a close. These are both or equal to, so they're both going to be closed. It's both going to be closed in the middle. And then here, they are both open at the end because they're both less than. We're going to be both open at the end there. Okay, so it's going to take a second here to understand everything going on. But let's go through. You know what? We're going to not worry about domain and range here. We are actually scratching that off. That's not going to be part of any questions here. So you can take that off. So let's do some more problem here. If you guys ever want to pause the video and try it on your own, feel free to do that. But I will move on and try. Okay, so once again, we got another crazier graph here, but we're going to make all our values here from -6 to -2. So -6, -5, -4, -3, -2, X and Y. And they're both we're gonna start with a closed dot, end with a closed dot, because that's the way our symbols are marching here. So let's plug these numbers in here. We got -6, if we plug in for X, that'd be -12 plus 5, that'd be -7. Next, we'll plug in -5, that'd be -10 plus 5, that's -5. Plug in 4, we get -3. Plug in -3, we get -1. Plug in -2, we get +1. So I'm going to plot those points. Let's see, that would be 6. So 8, this has got to be careful with oh, actually, -6 right here. We go down to -7. And then -5, which is right here, goes to -5, right in the middle. And then -4 goes to -3. -3 goes to -1 right in the middle. I'm just doing my best to estimate here. And -2 goes to 1. So I'm going to make sure I know that connect those dots. So there's our first piece of the piecewise. Next, we'll move on the middle piece. Every number between -2 and 1. So -2, -1, 0, and 1. All right, we're going to plug these numbers in here and see what happens. All right, if I plug -2 in for this one, -2 squared is 4. 4 times 2 is 8. 8 minus 7 is 1. All right, if I plug -1 in, -1 squared is 1. 1 times 2 is 2. 2 minus 7 is -5. Ooh, man. All right, plug in 0. 0 squared is 0. 2 times 0 is 0. 0 minus 7 is -7. And plug in 1. 1 squared is 1. 1 times 2 is 2. Now, our graph is going to start with an open dot, end with an open dot. So open, open. All right, so at -2, I'm going to put an open dot at 1, which is in fact right on top of that closed dot, which happens. It actually makes it a function. All right, -1 goes down to -5. 0 goes down to -7. And 1 goes down to -5, and we're going to make it an open dot. So you can see when we went here, we went down and then back up, which hopefully we kind of remember from our parent function activity. This is an x squared, so that is going to be a parabola. It's just a really skinny parabola. I'm trying my best here, but we go down and then up. All right, and then lastly, we got this one, -4 minus x, and we're going to put the numbers between 1 and 3. So 1, 2, and 3, and they're both going to be solid dots because they are both less than or equal to. So plug in 1, -4 minus 1 is -5. Plug in 2, -4 minus 2 is -6, and then we get -7. So let's see, 1 would be at -5, which actually is right where it starts. That's nice. 2 would be at -6 down there, and 3 would be at -7 right there. So a short little. So just our 3 pieces that we graph. There we go. Don't worry about domain and range. Intervals are increasing or decreasing. It's getting kind of crazy, and I won't let you guys do it. Biggest thing is here is if you guys can evaluate and plot the points. Okay. So on the back here, there's always some nice things, rules here, and I'm just visually showing you guys the same thing that we've been doing. All right. So piecewise function has different rules for different parts of its domain. And each one of those just kind of depends on what we're looking at. Okay, so here we go. We're going to look at the error here. Rebecca says there's an error and there's an open circle when x equals 4 for both pieces of the function. Explain her error. Okay, so if you were going to do this here, let's look just specifically at 4. Okay. All right, so if x equals 4, which one would we plug it into here? And this is what you guys will do on your CYU. If I say x is 4, am I plugging it into the top one or the bottom one? Both of them have a 4, but which one equals 4? And that would actually be the top one here. So if we plug it into the top one, we'd have a 2 times 4 plus 5, which equals 9. So there should be a solid dot at the point 4, 9 on our graph, like if we made a table. Now what we kind of want to do here too is to double check. You don't have to do this, and this is getting to something that you would cover in like pre-calculus, is okay, what about that other point here? Because we would have an open dot somewhere when we plot our points. And let's see, if I plug 4 into this bottom one, that'd be negative 16 minus 7. That'd be 9. So there is an open circle when x equals 4, but just for the bottom equation is open. But this one here, the top equation. Okay, so I'm going to help you guys out. That is it with the CYU here. I'll go over one of the problems so you guys are familiar with it. So in the CYU today, what you guys need to do, there's just one, because we're only spending one day on this section, is to go through and evaluate. There's this one multiple choice question here, which you guys should be fine. Remember, you guys get unlimited attempts, so take guesses. I think this one might pop up different multiple choices, but do your best that you can. Okay. So what you guys will see here is like this problem here at the, we'll do this middle one. I give you guys f of values. You just need to determine it, what it is. So, okay, if I say find f of 0, are you plugging 0 into this top equation or bottom equation? Well, 0 is less than 1, so we're going to plug into the bottom one. 0 squared plus 3, well, that would be 3. All right, now 2. Does 2 get plugged into the top or bottom? 2 is greater than 1, so we're going to plug it into the top. So what's 2 times 2 plus 1? That'd be 5. All right, now 1. Where are we plugging in 1? Is 1 less than 1, or is it less than or greater than or equal to 1? It's greater than or equal, so we plug it into the top. So 2 times 1 plus 1, that would be 3. All right, what about negative 4? Which one does that get plugged into? Negative 4 is less than 1, so we're going to plug it into the bottom. Negative 4 squared plus 3, that'd be 16 plus 3, 19. And then 5. 5 is greater than 1, so we're going to plug it into the top. And that would be 11. Okay, so hopefully the CYU isn't too bad. Hopefully you guys are seeing, getting the hang of things. If you guys have any questions, remember you can always reach out, email me, or just see me in class when you see me, or on the Zoom sessions. All right, so I'm going to end it here. You guys have a great day. See you next time.